Okay, pre-cal Longhorns. This is the test 3.2 review for our test on Tuesday, and I'm going to quickly go through all of the examples that are on your review sheet, and I wish you lots of luck on your test. Alright, number 1, simplify the following equation in radical form. Okay, so we're going to change this equation into radical form. And all you have to do is remember that the 7 that's in the denominator right here is actually going to be the 7 that's in our root for our radical. So we're going to write the radical, and we're going to put the 7 right here where the root is. And inside the radical, we're going to put our 2a to the third, and we're going to raise this radical to the third power. So the 7 that's in the denominator is our root right here. Then we put what's inside the parentheses. We're going to put that inside the radical. We use another set of parentheses to go around the radical, and we raise the radical to the third power. That's all. All right, in question 2, we're doing the reverse of what we just did. We're taking our expression that's inside our radical, and we're going to express this with an exponent rather than as a radical. So we take what's inside the radical, we're going to put it inside parentheses, and then we're going to raise it to the 4/5 power. So our exponent is 4/5. Let me write that again. There. 4/5. Okay, in this question we are simplifying this, and our answer should contain only positive exponents. So the first thing I'm going to do is I'm going to multiply this exponent times this exponent, and what I end up with is p to the -3/6 or -1/2. But I'm going to go ahead and just write it 3/6 for now. And then I can simplify that down to p to the -1/2. But I still have this times p to the 4th. So if you remember, if you have this a common base, you add the exponents. So now what I need to do is add the -1/2 plus 4, and that gives me p to the 3 1/2, or we could say 7/2. Okay, and that's it. You can get these fractions from your calculator if you're not really good at adding fractions with integers and you're not sure how to do that. Just add -1/2 plus 4 in your calculator, and it will give you 7/2. Okay, in the next problem we are simplifying the following equation. Exact answer, not decimal. Alright, so that means that we're not going to put this in our calculator. Alright, so I'm going to multiply the numerator and denominator by √5. And when I do that, I get 7√5 in the numerator, and I get 4 times 5 in the denominator, which is 20. And that is all you have to do. Alright, for number 5, simplify the following equation. Exact answer, not a decimal. Alright, first of all, we cannot subtract these because the number that we have under our radical is not the same number. So in order to subtract these, we have to have the same number under the radical. I can, however, simplify this radical because this radical, this 27, is actually 9 times 3. And I can take the square root of 9. So I'm going to rewrite this whole number right here. I'm just going to rewrite it. -3 square root 9 times 3. Okay, so now what I can do is I can take the square root of 9, which is 3. So that gives me -3 times 3, and now I still have a root 3 because that's what's left over after I take the square root of 9. Take the square root of 9, I get 3, but I still have this root 3 left. So I have to keep that under the radical. Now I have negative 3 times 3, root 3, and I can multiply these two numbers together. So that will give me a negative 9 root 3. Now remember, we still have to subtract this. So I'm going to bring it down, and I'm going to say minus 3 root 3. So my final answer is going to be negative 9 minus 3, which is negative 12. And we have a root 3. And that's it. Okay, for a problem like number 6, all you have to do is FOIL this. You're going to multiply these two together by FOILing. So I know that a root 2 times root 2 is just 2. And I know that a root 2 times a negative 3 is negative 3 root 2. And then I have to do the inside, which is negative 2 times root 2, which is negative 2 root 2. And then the last term is a negative 2 times a negative 3. That's a positive 6. Now I'm going to combine all my like terms. I have like terms here, and I have like terms here. So let me add the whole numbers together. I have 2 plus 6 is 8. And then I have a negative 3 minus 2, which is negative 5 root 2. And that's it. All right, the next problem we have, number 7, is a word problem. It's a financial problem, and we're going to use our exponential formula to solve this. And we're going to use the formula, let's see, this is June deposited $1,500 into an account that has an increase rate of, or an interest rate of 3.9% compounded quarterly. Okay, so this is a compounding problem, so I'm going to use my compounding formula. And my compounding formula is A equals P times 1 plus the rate in decimal form over N to the NT. So I just need to identify what all the parts are and then plug it in. Well, P is 1,500. And R is 3.9%, which in decimal form is 0.039. That's what it is in decimal form. N is going to be quarterly, so 4 to the 4 times 4 years. So quarterly 4 times 4 years. So you could write 16 there if you wanted to instead of 4 times 4. And then I just put this in my calculator and I get my answer. All right, so after putting it in my calculator, I get $1,751.92. Okay, the next problem. In 1985, there were 438 cell phone subscribers in small town Centerville. The number of subscribers increased by 65% per year after 1980. How many cell phone subscribers were in Centerville in the year 2000? Okay, so from 1985, we had 438 cell phone subscribers. So we're going to start with that year. And then we increased by 65% per year. So this is not a compounding problem, so we don't need N. We just need to put a 0.65 in here. And then we need to raise it to however many years. Well, I'm only going from 1985 to 2000, so I only need to raise that to the 15. And then I get my solution from my calculator. Okay, so I get the answer 801,186. So quite a lot more from 1985 to the year 2000, but now there's billions of people with cell phones. My, how things have changed. All right, in the next problem, we have George deposits $1,000 in an account with 7.4% interest compounded continuously. Now, this is your clue right here of which formula to use. Continuously means we're going to use P times e to the RT. And sometimes we call it PERT. It's not really PERT, but it's just an easy way to remember the formula. So we start with the principal, 1,000. We use base E from our calculator, and then we raise it to the interest rate 0.074 times the time. And the time is 20 years. And then we just put that in the calculator and get our answer. And we get $4,392.95. Lots of money. Okay, next problem. All right, for this one, we're gonna find A and B, and state if the function represents exponential growth or decay. So A is simply this first value right here in front of the parenthesis. That's 1/3. B is the value inside the parenthesis, or 7/2. And since 7/2 is really 3.5, 3.5 is greater than 1, this means that we have growth. All right, in this last problem, we're going to simplify the following equation. Exact answer, not a decimal. All right, so here we have 2 plus root 6 in the denominator, and we need to simplify this. So what we're going to do is we're going to multiply the denominator and the numerator by the conjugate of the denominator. So I'm going to multiply by 2 minus root 6. 2 minus root 6 in the numerator as well. And I know you all remember using conjugates. It may have been a couple of weeks since we've used them, but it's the same rule applies here that we used before. Okay, so we're going to FOIL this together. So 2 times 2 is 4. And 2 times negative root 6 is negative 2 root 6. And then 2 times root 6 is positive 2 root 6. And then positive root 6 times a negative root 6 is a negative 6. Okay. So now we are going to, that's going to be our denominator. Our numerator is going to be 3 times 2, which is 6, minus 3 root 6. And our denominator now is going to be this stuff right here. So 4 minus 6 is negative 2. And the negative 2 root 6 plus 2 root 6, well, those just cancel out. So we're just left with this negative 2 in the denominator. And now since we can't reduce this, we'll just leave it the way it is. All right, so we can't reduce the 6 and the 2 because of the 3 right here. This 3 doesn't divide by, is not divisible by 2. So since this is not divisible by 2, I'm not able to reduce this. I'm just going to leave it like it is. And that's the final answer. Okay, joke of the day. There are 3 kinds of mathematicians: those who can count and those who can't. Good luck on your test, Longhorns.